formulas for an indicated variable. All right, so all this means is you got to get the indicated variable by itself. So my first example, it says solve the formula for h. So I find my indicated variable, it's right here. I need to get this h by itself. So first things first, because we have fractions, we want to get rid of all the denominators. So I'm going to put parentheses around my capital R plus h, and I'm going to multiply capital R plus h to both sides. And while we're here, I'm going to multiply this capital R squared to both sides. And then looking at the left and the right hand sides, we're going to cancel out. So the R plus h's, they'll cancel here. R squared and R squared cancel there. So I'm left with capital R plus h in parentheses v squared equals 2g times capital R squared. Now, do not distribute the capital V squared. At this point, we need to get this little h by itself. So starting with this capital V squared being multiplied to this set of parentheses, we're going to divide it over to the other side. That way the parentheses are gone, and now I can get rid of capital R by simply subtracting it over to the other side. And now I solved for h. All right, my next problem, it says solve the formula for s. F equals s times g over s plus v. Here's my dilemma. There's two s's in the problem, and I can't cancel these s's because this is part of a binomial. So I'm going to get rid of that binomial, just like we did with the r plus h. I'm going to multiply s plus v to both sides so I can cancel those out. We never want to have fractions. All right, now in this particular case, because there's an s inside the parentheses and an s on the outside, I do need to distribute this f so I can group all my s terms together. Again, over here, I didn't distribute because there's only one h in the equation, and I don't need to combine it with any other h terms. So here we'll distribute that f. So what I want to do now is I need to put all my s terms together. So since sg is over here on the right, I'm going to subtract fs over to the right-hand side. Now, I can't combine these two, but what I can do is get one s by itself. Since I put all the s terms over here, I'm going to factor the s out as a GCF. So now fv equals s times the parentheses g minus f. So I went from two s's now down to one s. That was my goal. So to get rid of this quantity being multiplied to my s, we're going to divide the g minus f over to the other side. My s is all by itself, and we're done. My next example, we're looking to solve for a. You have 1 over a plus 1 over b equals 1 over c. So that's the variable I need to get by myself. It's in the denominator. In fact, I have a bunch of denominators. So I need to take a, b, and c, multiply them all together, and call that my least common denominator. And what we're going to do with that ABC is we're going to multiply it to both sides. So we're multiplying it to every single term. So ABC will be multiplied to the 1, this one, and ABC multiplied to that one. And what we can do is now you can cancel the A's. That leaves me BC. Cancel the B, leaves me AC. Cancel the C, leaves me AB on the right side. What happened here is I went from one variable a now to two variable a's in my equation. So just like we saw in the last problem, we need to group the two a terms together. So since AB is over here on the right side, I'm going to subtract AC over to the right side and do that same trick I did on the last problem to go from two a's to one a, factor out the a as a GCF, And as soon as I do that, we'll divide over the b minus c in parentheses to the b times c. A is by itself, and we are now done. The other concept in this section is going to be variations. These are special functions. They're variation functions. We have a direct variation, an inverse variation, and a joint variation. Now, all these variations are going to have a variation constant. Notice I spelt it with a k because it will be the variable k in the formula. And we will need to find the value of that k once they give us numbers for variables. So a direct variation is where k is multiplied by the independent variable. And you will see the phrase y varies directly as x. So what this means is right away, y varies means y equals k. Directly means I need to multiply the k by whatever variable is listed here. So we're going to multiply it by x. And there is my direct variation equation. Inverse variation, now the k is divided by x, not multiplied. So if you see y varies inversely as x, again, y varies, whatever to the left of the word varies becomes that variable equals k. Inversely says to now divide your k by x, so we'll put a fraction bar and we'll divide it by x. And there's my inverse variation formula function. Joint variation means k is multiplied by two or more variables. So if you see something like y varies jointly as x and w, y varies, y equals k, jointly multiply all the variables you see over to the right of jointly to your k times xw. Now, to solve variation equations, it's going to depend on how much information you're given. There's 3 steps. Number 1, write the variation equation. That's the first thing we do. It's usually in the first sentence or statement of the problem. Number 2, solve for k and rewrite the formula from step 1. That means they're going to have to give you all kinds of information except for k. So they'll give you the y, the x, the y, the x, the y, the x, the w. You solve for k and rewrite the formula. This is usually in the second sentence or statement. And third, you solve for the indicated variable. Now they give you more information with one of the variables y, x, or w missing. Now sometimes they'll just give you 2 statements and you stop right there. So again, it's all going to depend on how much they give you. So in my first example, it says capital Y varies directly as the square of x. First sentence, build the formula. Y varies. Y equals k. The square of x is x squared. There's step 1. Now, second sentence, if y equals 9, when x equals 6, comma, that's a break. That's my second statement. Put in the 9 for the y, put in the 6 for the x, and 6 squared is 36. You can now solve for k. Divide the 36 over into the 9. I get 0.25 for my k. Take that value for k, rewrite the formula in step 1. Y equals 0.25x squared. Done. Now, third statement. Then, what is the value of y when x is 8? So now you take this new formula, put 8 in for that x. Okay, 8 squared is 64, 0.25 times 64 is 16. You're done. Next example, capital M varies inversely as the square root of t. All right, step 1, first sentence, make your equation. M equals k, inversely divided by the square root of t. So t is in the denominator, but it's also having the square root done to it. If m equals 3, when t equals 4, second statement, plug in the 3, plug in the 4, solve for k. Well, the square root of 4 is 2. Get rid of the division of 2 by multiplying 2 to the 3, make it a 6. Now put 6 back into the original formula. Capital M equals 6 over the square root of t. Third statement, then what is the value of capital M when t is 81? Okay, let's go put 81 in for t into our new formula. Well, the square root of 81 is 9, and 6/9 reduces to 2/3, and we're done. Next, it says capital B varies jointly as C and D cubed. All right, here we go. B equals K times, jointly, times C, and then times D cubed. This does not indicate that C and D are both cubed. Only the D is cubed. If the C were to be cubed, it would say the product of C and D cubed. That means we're going to multiply C into D first, then cube it. So then you'd put parentheses around C and D if it said the word product. All right, second statement. B is 120, plug it in. C is 3, plug it in. D is 2, plug it in. We can solve for K. So we're going to have 2 cubed is 8 times 3. That'll be 24 times K. Divide the 24 over to 120, we get a 5. Plug the 5 back into the original equation, rewrite it. This is our new formula. Then, what is the value of B when C is 25 and D is 0.2? Plug those in. Crunch it out with a calculator if necessary. 5 times 25 times 0.2 raised to the third power. Oh, believe it or not, it's a 1. Okay, so capital B equals 1. Next, capital Y varies directly as the square root of x and inversely as the w. Okay, so you can have two variations going on at the same time. So y varies, y equals k directly times x squared, and then inversely divide the k by w. So there's my formula. Second statement, y is 8, x is 2, w is 5. Let's plug them in. All right, so we're going to get 8 equals 4 times k, or k times 4 over 5. Well, this is a fraction 4/5. Let's multiply by its reciprocal, 5/4. And that cancels. 4 goes into 8 twice. 5 times 2 is 10. There's my k. Rewrite your formula. Capital Y equals 10x squared over w. Then what is the value of y when x is 6 and w is 30? Okay, let's put it in. 6 squared over 30. Well, first things first, 10 can go into 30 3 times. 6 squared is 36 over 3, and then 36 divided by 3 is 12, and there's my final answer. And that concludes our section 7.5 and chapter 7.